problem, we are on the Long Island Railroad with Mario taking the train home at 5 o'clock p.m. and he gets home at 6:50. So let's just sketch that out, that Mario is starting somewhere, riding the train, and getting to the train station at 6:50. So here's Mario riding to the station, and he gets there at 6:50. Okay, and he leaves at 5:50. I think, no, 5 o'clock, sorry. So he leaves at 5 o'clock p.m. and he gets to the station at 6:50, and that, according to this problem, he's doing at the same rate. So he's constantly, every day driving at the same rate to Christina. Okay, so Christina is going to come and pick him up at the station. So at the station at 6:50 p.m., Christina, assuming she's not late, we don't hear anything about that, Christina picks up Mario. Right? We have to assume that she kind of gets there exactly when he does. We don't want any gaps there. But one day, Mario took the train home an hour earlier and arrives home at 5:50. So in this second scenario, we have Mario leaving earlier and an hour earlier, so he leaves at 4:50 instead of at 4 o'clock instead of 5 o'clock. And I'm not sure if that's very important information, but we'll figure that out in a little bit. I don't think that'll be important. Mario's here, leaving at 4 o'clock p.m. and getting home an hour earlier, so getting to the station now at 5:50 p.m. Okay, so he's getting there early, and Christina leaves at the usual time to pick him up, but Mario already began walking home. Christina meets him on the way, and they get home 30 minutes early. How many minutes did Mario walk? So I'm going to make a note of that. They get home 30 minutes early. Now, before we really dive into this problem and think about it, look how little information we have. We don't really know much about how fast Christina is driving. We don't know how fast Mario is walking. We just know that they get home 30 minutes early. And we know that Christina is traveling at a constant rate. And that's actually enough to solve this problem. A couple of things we can think about is that if, let's go back to our first normal scenario. Mario leaves at 5 p.m., but more generally, Mario leaves at 5 p.m., but we don't need to know that. That's going to cross it out. That's not going to help us. And I think you'll see why in a moment. We really need to look at is the journey that Christina's taking. And we don't even need to write down what Mario's doing here. It's not going to really help us. Instead, let's look at what Christina's doing. In case number 1, she's leaving at some time before she gets to the station, right? She has to leave before she can get there. So I would call this starting point 6:50 minus that time. And that is normally what she would do. She would leave, go to the train station, and then come back. It's a round trip, so she has to come back as well. Come right back at the beginning. Or you can think of it as an extension here. And that's back home. We'll call this home. So, or you can write it this way as a return trip home. So you start at home and you end up back home. So normally what's going to happen is that she's going to start at home before 6:50, some amount of time before that, some amount of time t less than 6:50, and then get home sometime after 6:50. So, and I'll write that up here so as not to confuse my timeline. So, okay. After she picks Mario up, they get home at 6:50 plus some amount of time. Who knows how long it takes them. Now, in this case, down here, altogether, what's that? Well, we have to find the distance of this line. We're going from this point all the way back home. So one way to do that is subtract. And you can think of 6:50 plus t minus 6:50 minus t, which is equal to, this is going to be subtracting a negative t, it's plus t, so it's 2t. 6:50 minus 6:50 is 0, and we get 2t. So normal travel time is 2t. This is normal traveling time. And that makes sense. It's easier to think about because we have this time here, this distance to the train station, and the exact same ride on the way back. So we have 2 t's, and that's the normal travel time to complete this pickup. But here we don't have that. We have Mario getting home early. And we were told that Christina, after picking him up, immediately get home 30 minutes early. And that's what I wrote here to keep track of that. So, again, we leave home. She's going to leave home at the same time. So she's going to leave at 6:50 minus t. She's going to go along, get to the station, or, well, we don't know if she gets to the station, and probably doesn't because Mario's walking home. So they're going to meet before that. Okay. So she leaves at 6:50 minus t, and is going along, and then meets Mario at some point. He's excited, gets in the car, and then they drive home. And we know that when they get home, it's 30 minutes early. So what does that mean? Well, ordinarily they would get home, according to our original model, at 6:50 plus t. But they're not doing that here. They're getting home at 30 minutes early, so it's 6:50 plus the time it takes usually for them to get home, minus 30. And that tells us this time right here. And now we're on our way to figuring out how many minutes did Mario walk. So what do we do next? Well, if this whole distance was 2t, what is this distance right here? We can measure it the same way. 6:50 plus t minus 30 minus, we're subtracting to find the distance, 6:50 minus t. So again, the 650s will cancel out. I'm left with t minus 30. This is minus a minus t. So it's plus t, or plus 2, plus t. And we get 2t, combine the like terms, minus 30. So we have 2t minus 30 is our trip distance today. And since we're traveling constant, it's all about the fact that she goes along to meet Mario, and then spends the exact same amount of time getting home, almost as if he runs and jumps into the car. So altogether, that's 2t minus 30, which means that each little half, right, this is a halfway point in time when she meets Mario, is going to be half of that. So 2t minus 30, that divided by 2. Well, 2t divided by 2 is t, minus 30 divided by 2 is 15. So each chunk of time here is the time minus 15, both sides. So she's saving time because she has to go a shorter distance. So it's the time she usually takes minus 15. Well, what does that mean? Well, usually she goes to meet Mario at 6:50. She gets there exactly when he does. So I can clear some of this out now. So she gets there exactly when Mario does. Let me clear this. Sorry. If she gets there exactly when Mario does, oops, I guess I can leave this. She gets there at 6:50, because that's when Mario gets there. But now we're saying, well, the time that we get there is minus 15, so it's 15 minutes sooner. So she's going to meet Mario at 6:50, right, minus 15, which means she'll meet him at 6:35. That's when she meets him. But that's not what we're looking for. So she meets Mario here. What does that mean? Well, he had been walking since he got home. He got home at 5:50, and it's now 6:35, which means he's been walking, well, 6:35 minus 5:50 is how many minutes? It's 35, it's 45 minutes. So he had been walking for a while. He had been walking for 45 minutes before Christina could pick him up. And notice, look at this problem. We're given so little, but we can still find our way to the amount of time that he was actually walking in this problem.